Hey everybody, it's Monty, and this is what I call the advanced geometry video for the week, shapes and probability. We're really getting spread out. Some of you are just finishing trig, some of you are just getting started on circles and shapes, others of you are finishing shapes, and you're moving into probability. So, two different videos for the same week depending on where you're at. Week 34, May 24th to the 28th. It's the last week of May. There's a holiday coming up, Memorial Day, yay! Okay, so let's get started on shapes and probability. Okay, so remember you can always go to our geometry team and you can see all the videos for the week, posted every week, and there's a stream channel. A lot of you just go straight to the internet, digital tools, Clever, Blackboard, and then we find our actual class. We scroll around, we find Geometry B, and we can see that all the videos are posted, one right on top of another. Boom, 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 boom. So you can go back and watch any of the videos to see how to do some of those problems. Now, cheat sheets, okay? If you need the trig cheat sheet, it's way down low. You can go find that, okay? Here is the shapes, okay? And for shapes, shapes, okay? And the formulas that you need, right? 2 pi r squared. Then for those of you moving into probability, click here. And probability is cool because, no, we don't want that one. Oh yeah, over here. Okay, so probability. Okay, in probability, what is the odds on things happening? How many different ways is there to align things? Okay, and here's our formula sheet. We're going to be working with dice. We're going to be working with cards. We're going to be doing Yahtzee. And what are the probability of picking certain types of potato chips out of 36 possible choices, like on this cookie one? All right, so those are the types of problems we're going to be doing. All right. So we're in our class, we click on Math Excel. Now, this particular video is for those of you that finished trig, finished the circles, and we're doing some of the volume, finishing the three-dimensional shapes, and then we're heading down here into these probability. Okay, so I think for this video, segment of a circle, we've already done that. Build a three-dimensional figure. Let's build a three-dimensional figure in this video. Okay? All right. So a three-dimensional figure, if we take this little flap here and we spin it, you see how the top is flat? Can't be B. Now, if we spin it, you see how we get this like bowl shape? So it'd be like that bowl shape, like that bowl shape. We don't see the circular part like on for C. So I think it has to be A. Okay. And if ever you need help, view an example, because I love how they can create items. Okay. It's so hard for me to draw those three-dimensional shapes. So feel free to always click on the question help. All right. So let's do one up here. Let's see what this one would be. Okay? All right. So how many vertices in these vertices? Corner points. 1, 2, 3, 4, 5, 6, 8. 8. Ah, there's 2 choices. Okay. So now we got to read them, don't we? And WHCR, WH, WHFM, LCRHWFM. A. There's no A. There's no A. Can't be that one. Has to be. Oh, careful. Has to be that one right there. Boom. Okay. Cool. All right. So corner points, a little bit of vocabulary. Yeah. All right. Why didn't it advance? Continue. Oh, okay. We want to continue. Okay. So now. Edges. How many edges? Well, we have 4 on top, 4 on the bottom, and then we have the legs holding it up. 4, 8, 12. 12, 12. Okay, not FH. see, there's no segment. F to H is a diagonal, so it can't be that one, so it's the A. Okay. My head is always in the way. Continue. All right, now how many faces? Now faces can be kind of tricky. You have a top and a bottom, and then 4 around the edges, right? So in faces, I think 6. 6 and 6. Now we got to find the one that doesn't fit. I, L, H, M. I like that. F, H. F, H, W, M. F cannot go to H. That's a diagonal, so it can't be A. It has to be C. Cool. All right. Now, same idea. Just work through what's a base. Okay, we have 2 bases, right? Or do we have 1? Only 1 on the bottom, right? So there's 1 on the bottom. Check your answer. The prism. Oh, okay. So prism has how many bases? 2. Okay, so definition, right? I would have thought where it was sitting, instead it's like a tent. They're calling the ends the base, right? Okay, how many lateral faces? That's the sides, not the bottom. You know, so what? 1, 2, 3, 4. Okay, now it's going to count the bottom as a face. Oh my gosh, are you kidding? Lateral. 1, 2, 3. Oh my gosh. So they're saying this triangle is on edge. Okay. So you see how frustrating that could be. I don't want you to think that's going to hurt your grade. View the example. See how they go about defining the different shapes. Okay? All right. So these are all the different ways they ask those questions. Okay? All right. The height of this one, I'm going to assume this means the height. But now, yeah, I'm going to assume that it has to be 6.9. They wouldn't say the 13. Now they're going to say the 13. So it is standing on edge. So the way it's drawn, I missed every problem. Frustrating. Okay, so hopefully that was confusing. All right, give it a try. And so we just did 3-dimensional figure, volume and surface area. Let's try a review problem. And we'll try this one right here. Okay. All right. So in this one, we were doing the sector areas, right? And we had it written out, right? 2 pi r times the percent of the whole. Okay. We didn't do this one. Okay. So this one is just going to be 2 pi r. So in this case, the circumference is 2 pi r. Now I'm going to say the 18 is the radius. If you say it's different, that's okay, because 18 could be the whole diameter. But I'm going to go 2 times 18 times pi. So I have 36 pi is the whole circle. But we only want 30 degrees of the whole circle. Okay? So, again, I'm going to type that in, and you're going to see that 36 pi, parenthesis, 30 of the whole 360, close the parenthesis. Whoop. Close the parenthesis. It's going to say that my answer is equal to the correct one because I didn't multiply it out, I didn't simplify it and all that. Once you do that, be proud of yourself, you can move on. Okay? Alright, again, this is our advanced version. So let's get moving to, I love cross sections. Okay? What does it look like if you slice something? Okay? Can you see how you can take an ice cream cone and slice it to get a triangle? Again, feel free to click on question help because they have a better way of drawing those than I do. What does it create when you slice it? So when you slice a cone, you get a triangle. No, don't do that. Slice it, and you get a triangle. Oh, I clicked circle. Goofy. There you go. Boy, I'm missing a bunch of them on this video. No way today. Okay, take a tin can and slice it. Whoosh. Whoosh. Can you see the rectangle? See the outline? All right. So, rectangle. All right. Okay. So, and feel free to read solid on the plane. We can think the cross section is a thin slice, right? Okay. So hopefully that was helpful, and we do this over and over and over. Okay. So now we're at cross sections, equations of a circle. We don't teach circles this year, so feel free to click on one of these, and you could actually go through the examples. Okay, there's videos if you want. We don't actually teach this, but there's a formula you memorize so that you get the center of the circle. Okay. All right. Now I want to get to our first problem with spaces, probability. Okay, so what is the probability that you can spin the spinner and get an odd number? So the first thing you do is, how many total numbers are there? How many pieces of the pie? 8. Right, you got 8. How many are odd? 1, 2, 3, 4. Half of them are odd. Literally just type in 4/8. Your answer is equal, not correct, because we could have typed in 1/2. Okay? All right, so let's try the next one. Okay? Now, in these are called tree diagrams. Total number of possibilities. Okay? My advice, 1, feel free to click on the example and work through it. Okay? A-E-I-O-U. Now see how they don't draw the tree diagram? Okay, now read it in order. Use the tree diagram, the sample space for choosing an event, A-E-I-O-U. And then, okay, the first thing you do is draw a letter. Can't be A, can't be C. Those are numbers. B or D. Now, the next time you reach into a different bucket, you get a 6, 7, 8, 9. 6, 7, 8, 9. 6 7s. No, has to be B. So read it in order. Now, what are the possible outcomes? This is called the fundamental counting principle. Okay? And the very first item talks about fundamental counting principles. And in the fundamental counting principles, you take the total number of items in each group and you multiply them. That's all you do, right? Well, look at that. If it's this one, I have this 4 times, this 4 times, this 4 times, this 4 times, this 4 times. So 1, 2, 3, 4, 5 times 4 is 20. Otherwise, just count all these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Cool? All right. This is where we'd like you to be working for those of you that have been pushing yourself. Then we get to these dice problems, okay? Next week, I will start with the dice problem, okay? But for this week, I hope that you push yourself to wrap up your shapes. Don't worry about circles. And let's head to probability for the month of June. Have a great week, everybody. The Advanced Geometry Shapes and Probability video.